Okay, we're going to do notes today on the squeeze theorem. Very wordy here on the screen, as you can see, but it's really a simple concept, and I'll try to get through that on the picture below. So the squeeze theorem says that if we have three functions and f is less than greater or equal to g, less than or equal to h, in some intervals, this doesn't need to be the case all the time, just whatever interval we're looking at here, containing that number a, when pretty much coming down to here is that if the limit of the two outside functions, right, are the same at that letter a, then the inside function is also going to be the same. So I'll try to color code this a little bit here. So I got sky blue, I'll do that on top. So that will be H. I'll do purple, some type of purple shade on the bottom. And then right in the middle there, I'll do green. Hopefully this looks different enough on the screen. Yeah, close enough. All right. Kind of colored in more. So that green one's the one that's in the middle there, saying that, well, that if the limit of the top one and the bottom one is the same at this point A, well, then G is going to be the same as well because of this inequality error up here. So that's all the squeeze theorem says. What gets tricky, though, is setting up the squeeze theorem. That's where we can have a little bit of trouble. So let's go ahead and look at what that looks like. So for this first example, it's already set up for us, which is super nice. So it's saying for all x in this interval from -1 to 1, square root of x to the a plus 7 is less than equal to h, less than or equal to square root of 4x to the a plus 7. And we need to actually find this limit right here. So since this is true, I actually want to find the limit. So I'm going to use the squeeze to find the limit. So the limit as x approaches, again, I'm looking at 0 here. 0 of this left guy that's going to equal to, this one's just a straight up plug in, nothing fancy going on. This is actually just going to equal root 7. The limit as x approaches 0 of this 4x to the 8th plus 7. Again, you can just plug in the 0 right away, and you just get root 7. Therefore, the limit as x approaches 0 of h of x is equal to, it has to be the same thing, root 7, and that's by the squeeze theorem. Now, I didn't actually answer my question here. Well, I'm looking for this. Okay, so let's go ahead and do that. I'll do that in green. In order to answer this, I have to use my limit laws. So the limit as x approaches 0 of h of x plus the limit as x approaches 0 of 25. I have this first answer. It's root 7. And since this is just a constant, there's no x value to plug into. It's just going to be that right there. And that's it. And that's really applying the squeeze theorem. We didn't really need to look at anything. We didn't need to create the situation. Actually, gets a little bit trickier. And so let's go ahead and look at number 2, because that's going to be that situation where we need to create the squeeze theorem. So, picture is on the screen. All right. So to use the squeeze theorem to evaluate the limit as x approaches 0 of x, sine of 1 over x. So first off, we can't just plug in a 0. Reason being is because you plug in a 0, you're going to get a 0 times sine of 1 over 0. And 1 over 0 is either like infinity or positive infinity, and it's sine of that, which is oscillating, times 0. So we're not really guaranteeing that it's necessarily going to be 0, because all this weird stuff is going on. So we use the squeeze theorem to kind of verify that, yeah, it probably should be 0. But sometimes we can be surprised, like, oh, it's not that case. And that'll be something we look to down the road. But the easiest way to set this up, you have trig. For any trig value, you want to find the range. What's the lowest value of a sine function? What's the highest value of a sine function? So if I'm looking at any sine function, this is going to be true. If you notice, I'm not putting in that little part yet right there. So sine is between -1 and 1 of any sine function. You agree? No matter what goes in here. So that's why it's safe for me to put in that 1 over x. This is always true, no matter what. Okay? How do I make this middle one look like this right here? Just need to multiply this by x. What do you do in the middle? Got to do on the outside. So I'm going to get -x less than or equal to x sine of 1 over x less than or equal to x. Now I'm ready for the squeeze because I do know, real quick, if I plug in a 0 here, that's 0. Plug in a 0 on that end, that's 0, which means that that middle is going to be 0. So I know this, but I have to get it on my paper. So let's go ahead and use the squeeze. So the limit as x approaches 0 of -x is indeed 0. So the limit as x approaches 0 of positive x, it's also 0. So the middle one, which is going to be the limit as x approaches 0 of x sine of 1 over x, by default has to be 0. Okay. And in a nutshell, that is the squeeze theorem. So we have one where we have to just apply, and then we have one where we need to create and apply it.